Hello, my name is Brian Din, and along with my group mates Alex Robotham, Austin Frank, and Ryan Marai, we will be presenting our senior design project, the Centredale Manor Restoration.
In the 1940s, the Centredale Manor site was used for industrial activities such as drum reconditioning and chemical manufacturing. This continued until the 1970s, when two apartment buildings were built, which are still there to this day. In 1999, the EPA began site investigations and found contaminants in sediments and floodplain soils. In 2012, a long-term cleanup plan was selected, which was implemented in 2018. Today, the project is working towards remediating the Allendale Pond, which is highlighted in yellow.
The Allendale Pond is directly downstream from the source area, south of the Centredale Manor. The pond is roughly 15 acres in size and features a dam at its southernmost point and residential areas along its eastern side.
The primary contaminant of concern found in the Allendale Pond is 2,3,7,8-tetrachlorodibenzodioxin, or TCDD for short. The pond will be treated by excavating sediments and disposing them into landfills. Excavated sediment with concentrations above regulatory limits are considered hazardous waste and must be treated through incineration prior to disposal in landfills specifically designed to hold hazardous wastes.
Moving forward, we took the sampling points Lowero sent us and optimized them within Excel for use in ArcMap. This involved removing specific data categories that were needed for proper outputs, including X and Y coordinates, sediment depth refusal level, and TCDD contaminant level, which was given in nanograms per kilogram. Maximum values of duplicate data points were used to ensure that all above LDR areas were accounted for. Several modeling techniques were investigated. The most statistically accurate modeling type was ordinary kriging with a logarithmic transformation applied to the discrete sampling points, shown above. The ordinary kriging model outputted a continuous concentration map from which we can pull sediment volumes from. Areas shown in red are above our LDR limit, and ArcGIS allows us to see their respective areas, which we can then transform into volumes, knowing the average sediment depth refusal of each area.
The excavation of Allendale Reach and Pond will take about 6 months over the summer. Prior to beginning the actual excavation, the site will need to be prepared by draining the entire pond, rerouting the reach with pipes, and preparing the access road for excavation equipment. During the excavation, all sediment in the reach will be considered below the regulatory limit. For the pond, about 65% is considered above the regulatory limit and 35% is considered below based on our model output. It will be extremely important to keep sediment above the regulatory limit separated from sediment below the limit throughout the entire process. Overall, 115,000 tons of sediment will be removed from the site. Once excavated, the sediment will need to be stockpiled to passively reduce its water content. Because the sediment needs to have a minimum compressive strength for transport, some cement will also be added to the sediment. Finally, the sediment will be transported off-site. Sediment above the regulatory limit is considered hazardous waste and will be sent for incineration at $800 per ton, while sediment below the limit will be sent for disposal at a landfill at $70 per ton. Although the transportation and disposal of excavated sediment accounts for a majority of the total excavation cost, there are still additional costs associated with the excavation. Overall, the bottom line capital cost estimate for the entire process is just over $100 million.
The velocity of flow for the 100-year storm is important as it determines what type of stabilizing material can be used for erosion control, based on that material's velocity threshold. For the reach, the values for flow velocities were found by dividing the 100-year storm flow rate with the cross-sectional area. Because the calculated velocity for the reach is relatively high, the best material choice is 6 to 12-inch cobble riprap. The high amount of impermeable pavement in the adjacent area and the high disturbance to the environment through the dredging process necessitates the need for erosion control. Any area of the pond perimeter that exceeds a 3-to-1 elevation ratio must have additional stabilization mechanisms in place to prevent erosion. We determined that our best available option is implementation of a coir log at the peak of the slope's elevation as well as at the water line. These logs are made from coiled coconut fibers and are fully biodegradable. To create the remediation framework of the wetland, we created a cross-section of the 5 designated habitat mitigation areas that are divided by elevation and characterized by different vegetation structure and ecological functions. Currently, Allendale Pond and its adjacent wetland is a highly fragmented environment that is overrun with invasives and has limited functionality. It is the hope to restore the wetlands to a robust and resilient functioning ecosystem. Local species of trees, shrubs, and macrophytes were chosen to be planted to reduce erosion and increase function of the wetlands. Considerations were also made for the wildlife, including bats, birds, fish, and turtle.
Thank you, and I hope you enjoyed our presentation.